Hi, everybody. I want to put together a recording just to kind of go over some of my thoughts on chapter 1 of cloud computing and just kind of set the stage a little bit, maybe give you a different perspective depending on the way that the slides hit me tonight. So let's go ahead and just jump in and get started. And so we're going to walk through kind of the nature of cloud computing. We're going to talk about things that led to cloud computing. We'll describe virtualization and its role in cloud computing. We'll talk about the different cloud types, which include software as a service, SaaS, platform as a service, PaaS, infrastructure as a service, IaaS. And today, something that's changed is there's lots of things as a service. There's identity as a service, there's games as a service, there's you name it as a service, and it's starting to become, I guess we'll have social media as a service here soon, and they'll just post responses for you. And so as a service model is growing, it's not necessarily a bad thing. It brings together great opportunities for software developers, it brings great opportunities for new companies, but then it also brings benefits of having a cost-effective way for people to enter into industries and participate with software platforms that before the cloud might have been cost prohibitive. And so we'll talk about the benefits and disadvantages of cloud computing. I'm a big proponent, so I don't normally find too many disadvantages. We'll talk about some of the security considerations and at least the security perceptions of cloud computing. And then we'll make sure that we can describe some of the key benefits of cloud computing, where we've got scalability, we've got robustness, we've got reliability, we've got our service-oriented model. And then we'll talk about how WebPoint 2.0 really helped drive some of the success of the cloud, because it drove the user involvement in applications that were cloud-based. So let's go ahead and get started. So giving you a definition, and I'm always a firm fan of starting with a definition and a description of something. Cloud computing describes the abstraction of web-based computers, resources, and services that the system developers can utilize to implement complex web systems. And so what's the abstraction? Well, it is this thing that we call the cloud. And so why do we use the term cloud? For years, we, as network designers or software developers that were doing network applications, we referred to the internet as a cloud. We drew it as a cloud on the bulletin board or on the whiteboard or the blackboard, depending on how long ago it was. And that way we could ignore the protocols and things that were driving communication across the internet. We just assumed that they worked and they were there because we didn't need to drill into them. We could abstract them away as we were talking about the solutions that we were going to build. And so from that, cloud computing was kind of born. And it wasn't like cloud computing just happened. For years, we were doing things much like cloud computing. We just weren't calling it cloud computing. We had internet service providers where we were hosting websites, and we had active server pages running on internet server providers, which were a lot like maybe even a SaaS-based implementation of something. So the terminology has just kind of evolved over the course of time. But cloud computing, at least some of the initial concepts of it, aren't necessarily a new thing. Throughout the book, we look at a lot of real-world examples, and iCloud was a great early example of cloud computing. It gave us a place to synchronize our files and to store files, and it gave us a consistent view of this abstract data store. And so, yes, we were putting files out there, and we're pretty used to doing that today. I'm just putting my files in the cloud. But a bigger picture in that was it gave us a way to view those files in a consistent manner between our phone, our tablet, our computer, our desktop, however we were accessing the files. They were there in a convenient manner. And if we had similar files on our desktop, we could synchronize the two. It all just kind of happened. And today it's all become kind of old hat. We're used to storing things out in a cloud-based facility. And so one of the things that I worry about with respect to a cloud, and I say I normally don't find anything negative to say about the cloud, is we do have all these cloud-based data storage areas, and we've got folders within them, and employees access them, and everybody creates files out there. And then we get fired or we move on to a different job, and our files just kind of stay out there. And so we're building up around the cloud all these remnants of documents. And so there might be useful information, might be not useful information, but it's just now sitting out there. So all these remnants, where you used to have fragmented disk, I think we're starting to have fragmented cloud storage. So just something to kind of keep in mind as we start talking about remote storage. I mentioned the fact that Web 2.0 was kind of a big deal, and Web 2.0 was Time Person of the Year, I don't know, a lot of years ago, but it was the people where we were posting in social media, we were posting on Facebook, we were posting on Twitter, we were posting on Instagram. So we were driving and creating and initiating content ourselves. And there was a lot of ways we could do that. We use blogs, we use wikis, we use Twitter, we could use Facebook, we post videos on YouTube, we do things on Instagram, we could do Snapchats that went away after a few seconds. But in any case, we're using the cloud-based solutions to create content that others were interacting with. And that really helped drive some of the acceptance of cloud-based applications, as well as the use of the cloud. And so when we talk about the cloud, we tend to even categorize it even further, and we break it down into different types of clouds, where we have community clouds, like maybe a cloud to be shared within a school. We have a hybrid cloud, which is some combination of the different cloud types. We have private clouds, which belong to just one business or one company or one school that they're not sharing. We have public clouds, which are kind of repositories where we might have even competitors in the cloud, but they're still segregated, so it's safe to use. And so there's a variety of cloud types. And then our key applications are within the cloud are software as a service, our Salesforce model, our all the models of applications that we deal with today that are web-based. We refer to those as SaaS. Platform as a service, we're not just interacting with one software program, but rather we're, as the developers, going to get an operating system pre-installed, and then we're going to install our software on top of it. And we're going to let a cloud service provider manage the operating system, manage the updates. They might even have some databases that they're versioning for us and keeping patched and keeping secure. And then there's infrastructure as a service, where they just basically give us hardware out there. We then manage the operating system. We then do those installations, those patches and things. And so we can get as granular as we want. We just say, I just want to put my software application out there. I want to be able to get to the operating system. I want to be able to install the operating system. So kind of three key levels of the cloud. And we talked about the different cloud deployment models, from private clouds, public clouds, community clouds, hybrid clouds. Hybrid is always a combination of something. In the community clouds, I would think of as just one school. Maybe even your church has some kind of shared cloud between the people who attend the church, and so it becomes a community-based cloud. And we talked about our different models: software as a service, platform as a service, infrastructure as a service. You should be able to quickly describe what each one of those means. And if given a scenario, I'm going to use hardware, you'd say infrastructure as a service. I'm going to install the operating system for you. You can put your application on, you'd say platform as a service. Or I'm going to offer you access to my program. It's web-based, software as a service. So you should have a good understanding of these key terms. I don't know how many job interviews I've been on where I've been asked, can you describe the difference between software as a service, platform as a service, and infrastructure as a service? That's kind of their cloud drill down. So again, looking at a real world model, today we'd probably look at Amazon as the leader in cloud services. Microsoft was late to the cloud. They were late to a lot of things, probably, other than maybe the LinkedIn application or acquisition. I'm not sure anybody else wanted to buy LinkedIn at the time, so they stumbled upon it. But they were late to the cloud, and their entry was Microsoft or Windows Azure. And it's a cloud-based platform for developers, and they provide access to MS SQL databases and things. And I've used it for a couple different applications. And what I found was it's expensive. And there aren't always bargains where you think you're getting bargains. And I got bills from Azure for small applications I thought were made Microsoft pretty proud of what they must be offering, because the bills were pretty great. And so I find that AWS is very, very secure. I had a couple of websites that were just simple websites for this book, for example, websites for my wife's ranch and things that were just simple sites, but every night they would get hacked. And people tried to attack them and attack them. We'd watch. There'd be people from Asia trying to attack them. There'd be people from Poland trying to attack them. It's like, what's your point? They're not e-commerce sites. They don't have government secrets on them. Why do you keep trying to attack them? So finally I moved them to AWS, and it just stopped. AWS is pretty locked down. And its downside is it can be cumbersome. It's got a lot of tools out there. There's a learning curve to get to use it. But it solved the hacking problem, and it solved it in a more affordable way than what I was finding with Azure. So that's probably my preferred orders. AWS first and Azure somewhere down the line. So what do we do cloud computing for? What are some of the benefits that we get? And so the first one is scalability. We talk about the elastic nature of the cloud, which means it can kind of grow and it can shrink with respect to resources that's providing for us dynamically. And so if our system starts to get overloaded, either with too much CPU processing, we can throw in another virtual CPU on the fly, and we can just pay for that kind of on demand. So we didn't have to reserve 2 CPUs and pay for 2 CPUs. We pay for what we're using. It's kind of a pay-as-you-go model, and we can scale up and we can scale down. And you'll hear the term cloud bursting, where we've got maybe something on premise, and when it gets too big, we scale up into the cloud, either for data storage or for more CPU utilization or database access or something. And so it's a combination of on-premise and cloud. Disaster recovery is always a critical issue, and the cloud, a lot of it can be taken care of for us. And so we can get better redundancy, we can have it can build in, we can have a hot server sitting just waiting to take over, put a load balancer between 2 servers and let them share the load, and then if one fails, so it just fails over hot. We can do the same thing kind of with storage with databases. And again, because the cloud service providers are having racks and racks and racks of servers, administrators who can monitor those, they have a pretty good economies of scale. So they have cost benefits through their resource pooling, which they can then pass on to us. So it is more cost effective to be in the cloud than to have your own on-premise. We can outsource our server management, which means I don't have to be in charge of operating system upgrades, patches, security settings, and things if I don't want to. I can let the cloud people do it. And they've got experts who are doing it on a regular basis, whereas in an on-premise situation in your data center, you probably have a network administrator who's also the Active Directory administrator, who's also, I don't know, the mail server administrator who's juggling all these tasks. Whereas on the cloud, we probably have just a Active Directory person, or we just have a network administration person, or a intrusion detection person. They can kind of specialize because they've got multiple systems that they're protecting. And so my argument is that they're probably better at it just because of their focus. Low cost of entry is a key thing, and it's driven a lot of applications because it costs a lot less to spin up an application and start using it on the cloud. Salesforce is the prime example, and God knows they get paid enough for Salesforce, but it's a lot more expensive if you're doing it on premise. And so we can get an ERP system today, an enterprise resource planning system today, that has an human resources, an HRIS system. It has a customer relationship management, a CRM. It has a supply chain management system, a SCM. It has accounting and financials. And we could get them all at once in the cloud, or we can get them one at a time in the cloud, depending on what our budget needs are, our requirements capability are, our ability to absorb new applications are. So there is a lower cost of entry. We've talked about software as a service. It provides a cloud-based foundation for software on demand. It's web-delivered content. This is where I said we're kind of doing it for a while using internet service providers and things, but call it what it is. Things got to be SaaS-based today. And some of the early leaders, Salesforce and things, kicked off the ball and got the door open for the cloud, and it's just run since then. Disadvantages of SaaS: they're less expensive, they're easier to manage, Cost economies of scale. Oops, those are all advantages. So disadvantages, there's a perception that those things in the cloud aren't as secure. And that's where I go back to my argument is with the cloud administrators are doing this full time. They're focused on just the security aspects. They're focused on malware. They're focused on intrusion detection. They're focused on denial of service detection and prevention. And so they're probably as good or better than what you can get on premise. Which means the security issues with the cloud are more of a perception possibly than a reality. And again, we talked about Salesforce, and it was one of the first companies to launch a large-scale software as a service solution. And today, it's leveraged the fact that 3/4 of a salesperson's day was spent on things that weren't sales-related. It was tracking things and copying things and moving things. And so it didn't matter what companies really did. Salespeople were doing the same type of operations. So Salesforce just made it available to everybody and made solutions available in the cloud. And they could still charge a lot for them. You can look at companies like Workaday. If you've ever been to the Bay Area, it's hard to drive a block without seeing a Workaday business tower. And so these companies have just experienced explosive growth funded by the cloud model, which is a lower cost, easier entry for customers. We talked about platform as a service. That's where I'm going to give you an operating system. You configure it, and you can configure your application on top of it. I'll worry about doing your patches for you. I'll worry about your security settings for you and things. Advantages and disadvantages. Developers can focus on the application. They don't have to focus on the underlying hardware or keeping operating system patches up. Disadvantage, some developers want to have those worries and want to do those things and want to be in a little bit more control. We talked about infrastructure as a service, IaaS, where I'm going to give you the hardware. I'm going to give you the disk storage, and you're free to install whatever operating system, you're free to install whatever file system, you're free to install whatever database system on top of them. And so I'm saying just the bare bones resources. Disadvantages and advantages of IaaS. Big one is you don't need a data center anymore. You should have your data center in the cloud. It's easier to replicate. It's easier to get to. I live in Arizona. We have great winters, but in the summer, sometimes we have power brownouts. So you can get your data center out of areas that are prone to that. Used to live in Houston. They had big bugs, they had big snakes, but when they flood well. And so you get your data center out of areas like that. And then the disadvantages, some people want to physically touch their server racks. They want to see their server racks. And for those, they're probably always going to be on-prem. And again, we talked about AWS, and yeah, I'm a fan. Yeah, they control the world. Yeah, they're a little complex. I like their multi-mode authentication. They've just got a secure system, and most of the tools they have make a lot of sense. And we talked about scalability, and it's the CSIRO application's ability to use additional resources on demand. Additional or less resources. We can scale up, we can scale down depending on what our needs are. And so when we've got high demands, we can scale up. When we don't, we scale back down, and we pay for only those resources we need. That's a huge benefit for the cloud. The cloud is inclusive of virtualization. I don't want to say that cloud is virtualization or virtualization drives the cloud, but cloud utilizes virtualization. And that's the use of hardware and software to create a perception of something. And I describe it like that because we've used virtual memory forever. Virtual memory just gives our program the illusions that they have unlimited physical memory, essentially. And so more memory than what the computer actually has in it. And it used to be a really big deal when we had limited amounts of memory in our computers. Maybe not so much anymore. We can start doing more things in memory. We got databases that reside in memory because we've got so much memory, it's cheap. But virtualization is creating that perception. And so we have virtual networks. What does that mean? It means we're segmenting our network to look differently than it really is. We have virtual desktops. So I can run Mac on my system. I can run Linux on my system. I can run Windows on my system. Just by using virtual desktops, I'm creating the illusion that I'm running that kind of desktop computer. And so again, we got desktop virtualization, allows a desktop PC to run multiple operating systems, ideal for testers, support personnel, developers who may need to develop and test for a variety of different operating systems. And so our key terms, we talked about Amazon Web Service, more better known as AWS, cloud computing, different types of clouds, our community cloud. I don't know if we talked about grid computing. A hybrid cloud's a combination of a public, a private, or a community cloud. We talked about iCloud. We talked about infrastructure as a service, platform as a service, software as a service. And so I think we hit most of these terms. And so, again, I'll try and do this each week, and we can kind of just chit-chat about the different technologies. And they're evolving quickly, which is exciting. They're getting faster. They're getting more secure. They're a lot of things that were once disadvantages may not be so much anymore. And we've got cloud service providers whose service level agreements will now virtually have 100% uptime. I mean, we used to be 4 or 5 nines. Now we're getting to be a lot of nines with respect to uptime and things. So the cloud has come a long way. So I look forward to talking with you all about different aspects of the cloud. Have a great week. I will see you in the threads.